Today, I will be discussing the educational emerging trend, 3D printing. I think many of you will enjoy this topic, as I know I was very interested in this topic when I was researching. There's so many educational benefits that our students can benefit with 3D printing in their learning experiences. So today I will be going over 3D printing and education is in depth the fused deposition modeling printers, also known as FDM design printers, how to effectively use 3D printing in your instruction, the significance it has in our education for students, and the 3D print across different subjects and what that looks like. What is 3D printing? 3D printing is the additive manufacturing process of creating physical objects using a digital design. So what additive manufacturing process means is it's just a term used for the concept of 3D printing technology. Thus, the digital model that is created, what happens is it's turned into a solid 3D figure or physical object. And this is through the process of adding layer by layer. Into a little bit more depth on how this process actually works. So this is begun with having what is called a digital 3D design file. And this is what you need for any physical object that you may want to have 3D printed. According to the article, what is 3D printing? The definitive guide. It says that this is what you would think of as a blueprint. So this 3D design file is a blueprint for a physical object. And if you're trying to print without this 3D design file, they put it in terms of it's like trying to print a document on a sheet of paper without a text file. So it's that same concept. Without this design file, you can't print digitally. This design file is sent to the printer, and what the 3D printer does is it slices the file into thin layers so that it can print it digitally from digital document to 3D physical form. There are various types of 3D printing process machine, just depending on the machine. FDM, which I defined as the fused deposition modeling printer, to more large printers that are used for industrial manufacturing. So the FDM printer melts plastic filaments, just like in this image to the left, the orange skinny string, that is what is called a filament. And then the large industrial printers, they can print different types of materials, such as melt metal powder to print a 3D object. I'm going to focus on FDM printers because these are the most affordable ones, and they're the reason that many schools can actually have 3D printers available in their in students' education. And these are the ones that most schools do actually have, since their price is right. FDM printing process. Again, this is what we're going to focus on, is the FDM printer. So this process, of course, it has to begin with creating that 3D digital file that we talked about. And this will be the model of the object that you want to create using a computer-aided design tool. So these are also known as CADs in short. This tool is something that teachers would have to in-depth and explicitly teach their students how to navigate and use before they actually begin the 3D printing process. So what are CADs, you must be wondering? CADs are what we define as computer-aided design software or tools. And these softwares, pretty much they simplify the design process so that students or adults can create 2D or 3D models used by architects, engineers, drafters, and many other types of careers in order to make precision drawings or technical illustrations. With the FDM printing process, after creating that 3D digital file of the object that you want to create, this process starts after that with a string of solid material called filament, and it is labeled in the picture to the left. Filament is attached to a heated nozzle on the 3D printer, and what that nozzle does is it melts the plastic so that the material can be placed onto the object that you want to print. And this material is extruded on a predetermined path that you have created already by the CAD software. And as it's extruded, how it's extruded is by layer. So layer by layer on that path. It goes down and solidifies. The next layer can be laid, and these filaments come in as many colors as you can imagine. So in order to be an educator and teaching 3D printing, teachers themselves would need to be trained, of course, on how to use these 3D printers so that they can go and then teach their students the entire process, and they can do it efficiently and effectively so that the students know how to use these 3D printers. To Hula Heel, it is very important that teachers teach technical engineering drawings to the students prior to the 3D printing process, because this will help them to comprehend what they're seeing when they're looking at different types of projections. And the types of projections would be the front, top, side, isometric view, orthographic view, and perspective view. And what the goal is that the learner can create these 3D models, whether it's from starting with the physical projections to the digital form, or vice versa, from digital to the projections. So seeing it in both angles, both ways. This process of 3D printing, it's a really important part of this process to have students actually observe what they've printed, so the 3D model that they've printed, because you want to promote them being innovative and thinking about, how can I improve this model, or how can I improve the function of this model. Instructional time, you want to make sure that you have a very systematic procedure to teaching this type of learning, hands-on approach, and you would want to make sure to keep everything moving along smoothly. Hill, he says, the combination of thinking, design, and production has immense power to increase motivation and satisfaction, with a highly probable increase in a student's math and geometry achievements. And we can see why, because 3D printing is such an engaging and inquiry-based type of learning that students can experience. So what's its significance in education? 3D printing is significant because it requires high levels of critical thinking in order for our students to create these 3D digital models. The students use and practice innovative skills because, as we mentioned before, they can have these opportunities to look at and test their 3D models that they've created, and they can determine how they can improve their model or their model's function. And essentially, those are all 21st century skills that promote problem solving. So they get to wake up their inner creativity and also develop abstract thinking through this process, because they're visualizing these numbers and these 3D shapes when they're configuring how to create these 3D models. So the CAD systems, what they offer to students is just a measuring tool that enables alternate ways for the students to calculate the object's properties. So like the measurements in the 3D models that they are needing so that they can create it efficiently. And it also allows for development or reflection and critical thinking, as we've discussed before. This type of technology is the type that scientists and engineers are using to change the world. Just an example would be engineers that create prosthetic legs to give people a second chance at being able to walk if they've lost a leg. So that is changing the world. Teaching and education offers opportunities for students to participate in what's called the learning process of project-based learning. So PBL is when collaborative teams work together so that they can solve real-world problem, and they can do this using 3D printing. So what the teacher would want to do is pose a question where students would use 3D printing to create a solution. And again, this is all part of the 21st century skills that we should be teaching our students. So across subjects, here's various ways I've researched on how 3D printing can be used across subjects and what it would be like. So for engineering design students, they can print out prototypes. Architect students can print out models of the designs that they've artistically put together themselves. Graphic students can print out 3D versions of their artwork. Geography students can print out topography, demographic, or population maps, which are very cool. Automotive students can print out replacement parts or modified examples, again, that innovative skill of existing parts for testing. History classes can print out historical artifacts for examination. Chemistry students can print out 3D models of molecules, and biology students can print various things out, such as cells, viruses, organs, and other critical biological artifacts. Students can print out problems to solve in their own learning spaces, whether it's from scale models to city infrastructural design challenge. Drastically participate in their classes because they're able to examine the products that they're actually creating, and their spatial imaginations are effectively stimulated because this process is so engaging. 3D printing enables students to transfer their ideas into reality, which promotes active learning across different subjects, and it helps the students to retain what they're learning. And according to James Reed, there has been a lack of students pursuing STEM subjects after graduating K through 12 education. However, this is something that schools and universities can change. He says that 3D printing can inspire curiosity in STEM subjects, which gives students the chance to understand complex concepts and test theories. So this can lead to experience and exploring careers in science and engineering. Tons of great info that will inspire you to use 3D printing in your practice as an educator. I know I am, because being that we need to prepare our students for a future that we don't know will be like, we need to teach them these 21st century skills, and 3D printing is an exact avenue that we can take to promote that. It is definitely an emerging trend, in my opinion, on the horizon that students will benefit from in hundreds of ways. Have a good day.